Hi everyone, in this video we're looking at tangents to curves. So a very quick definition here. If we have a function like a curve, then a tangent is simply the line that touches that curve at one point only. And the feature of that tangent is that for that to happen, it must have precisely the same gradient as the curve at that point, which means that our first step to finding a tangent is to differentiate. So we're going to take that function and differentiate it. So dy by dx equals 2x minus 6. Now, when we're working out a line equation, we have it in the form y equals mx plus c, where we have a gradient. And so we need to work out that gradient at that point 7. So I'm going to put the value of 7 into my equation. So my gradient is going to be 2 times 7 minus 6, so that's 14 minus 6, which is 8. Now up here I've got the gradient point equation, which is put on your formula sheet, and that's a way for us to find any straight line equation so long as you have a gradient and a set of x and y coordinates. So I'll demonstrate how we can use that. So I'll write it out. Y minus y1 equals mx minus x1. And so I'll start by writing it out again, and instead of m, I'm going to write my gradient of 8. So we have 8 bracket, and we're going to leave our x and y in there because we need an x and y in a straight line. Now I'm going to put my coordinates, my 7 in for x, and my 5 in for y. So I've got minus 5 here, and I've got minus 7 here. Now we're going to expand and simplify. So I have y minus 5 equals 8x minus, here's a test for my times tables, 8 times 7, 56, correct me if I'm wrong. And we can just rearrange that to y equals 8x minus 51. And so that's the equation of our tangent at the point 7, 5. So these questions are going to be pretty straightforward after you've done a few of them, and you can practice them on 21.03 on page 310. Thank you.